Hey everyone, in this video we're going to talk about exponential functions. We're going to review them. So the properties of exponential functions for something that looks like f of x equals b to the x. So what exponential functions come to mind when you see f of x equals b to the x? So you may think of f of x equals e to the x, or f of x equals 2 to the x, 3 to the x, all those, right? Or even fractions, 1/2 to the x. So those are all exponential functions. So the base is the constant and x, our variable, is the exponent. So the domain of all of this, right? Domain is all the values for which the function is defined. So is there anything that's going to make it undefined? Not really. So the domain of an exponential function is all real numbers. And the range, because when you start plugging in values, right, if you put in a negative number, what happens? So if you do 2 to a negative number, now that's going to make it, so for example, if I have my function f of x equals 2 to the x, if I do f of negative 3, what does that become? That's 2 to the negative 3. The exponent is negative, so that just becomes 1/8. So that is a fraction. So the question is, are we going to be able to get any negative numbers when I plug in x, right? Notice that if I plug in domain values, x values that are negative, that just makes the y value be a fraction. What about, can it be 0? Right, that would mean that 2 to the x equals 0. Can you think of an exponent that you can put on 2 or any number, right? B to the x is 0. Can you think of an exponent that whatever the value of b is, if you raise it to a number, that you're going to get 0? No, so this is not possible. So that means that our y values are never 0 and they're never negative. So the range is from 0 to infinity. And with f of 0 being, now if x is 0, you get the y value is 1. If b is greater than 0, then f is an increasing function. And why is that? Well, as we can see here, with f of x equals 2 to the x, 2 is a number that is bigger than 1. These values are going to be increasing. Right? Notice that when f is negative 3, when x is negative 3, you get 1/8. When x is 0, you get 1. If I try to find f of 2, for example, then I'm going to have 2 squared, which is 4. So these values keep increasing. So my function is going to increase. If b is a number between 0 and 1, then our function is going to be decreasing. So that would be like my 1/2 to the x here, right? So for a b to the x, for an exponential function, your values are going to be greater than 0 for b, but they can be fractions. So like 1/2, and they can be whole numbers as well. Okay, so let's graph some. Okay, so let's try this example. The following figure shows the graphs of all those functions. Match each curve with the correct function. So let's think about this. So notice I have A and B are decreasing and C and D are increasing. So that should help us narrow down which functions are which. And here, notice that y equals 2 to the negative x. So let me come back to the functions that I had written up here, right? E to the x, 2 to the x, and I had 1/2 to the x. All the exponents that I wrote were positive. And here I'm giving you some negative exponents, but they're actually not too different. They're just written different. So y equals 2 to the negative x. What does a negative exponent mean? Negative exponent means I can write it as a fraction, right? This is asking me for the reciprocal. So what this means is really that I have y equals 1/2 to the x. In this, then I can rewrite it as 1/2 to the x. So essentially when you see a fraction as the base, you can rewrite it as a b to the x with the x being a negative. And so y equals 3 to the negative x, that's really y equals 1/3 to the x. So that's another way that you can think about this. And the general graph of an exponential of, let's say, y equals b to the x for b greater than 1 and positive exponent. The general graph of this is the parent graph, right? The exponential function, which is, see if I can graph it real quick, freehanding it here. So this is your standard increasing function. So it's 0, 1, and then the domain, right? All real numbers, so minus infinity to infinity, and the range 0 to infinity. So I always say that you always have your exponential graph on your right hand. So if you look at your right hand, so let me turn on my camera real quick. So if you look at your right hand, and I don't know how it's showing in your video if I'm mirrored, but I am looking at my right hand. So if you look at it, you will see right underneath your pinky, there's a line. And then if you follow that line to your index finger, that is your e to the x. I'm going to put my thumb down so you can see. So you have your below your pinky, and then that's your e to the x. So of course, when you're looking at it, then you'll see your e to the x. Well, your increasing exponential, your b to the x line in there. And then for the decreasing one, your 1/2 to the x or 1/3 to the x, look at your left hand. So it's going the other way. All right, so now that we know that nice little trick about our hand and increasing and decreasing exponentials, which graphs matches which? So y equals 2 to the x. What do you think? So I'm going to use my red pen here. Oh, I guess not. Y equals 2 to the x. What does that look like? So all of them, notice that when x is 0, the y-intercept is going to be 1. That's why they all go through 1. So the next thing is to look at, okay, what about when x is 1? So when x is 1, what is the y value? So what is that one? And what is that one? So when x is 1 here, y is going to be 2 to the 1, which is 2. And so which one is that? And then when x is 1 for 3 to the x, you're going to have y equals 3 to the 1, which is 3. So then looking at these two, well, which one is which? So that means that D is the lower one, right? Between 2 and 3, 2 is the lower one. So this will be y equals 2 to the x. And then C over here, this one will be y equals 3 to the x. And we can do the same thing with y equals 2 to the negative x and y equals 3 to the negative x. And again, you can change those to 1/2 x to the x or 1/3 to the x. And so for the negatives, I can look at the -1. When x is -1, these are my values. Whoops, not those. Just kidding. Those are not my values. I'm looking at A or B. So it's going to be here or here, right? So then that means that when x is 1, if I'm looking at y equals 2 to the negative x versus y equals 3 to the negative x, when x is 1, -1, you're going to have 2 to the -1, which is 2 to the +1. And you're going to have same thing here, 3 to the -1, which is 3 to the +1. So same thing. So that means that B is going to be y equals 1/3 to the x or 3 to the negative x. And A is going to be y equals 2 to the negative x or 1/2 to the x. And again, that's just by doing properties of exponents. A negative exponent means I have the reciprocal. All right, so we're going to go on to What about e to the x? What is the number e? So that's going to be our next video.